Hi guys, welcome to Percona Community Live Online 2022. Hope you are already enjoying the presentations and sessions. And okay, so my name is Sakthivel. I am working as a MySQL DBA at Percona, and today I am going to present the topic overview of different alter algorithms and its locking scenarios in MySQL. Okay, so this is the complete demo session. So I am going to show everything in the demo. So I hope it will be helpful for someone. Okay, fine. So this is my agenda of the talk. So I am going to cover the three major topics, which is first one is the overview of different locking options and overview of different algorithms with the demo and the role of old alter table. Okay, which is a parameter, MySQL parameter, and we will see how the alter is working with enable of old alter table and disable of old alter table. Okay, fine. So the first one is the overview of different locking options. So we have totally three locking options for DDL. One is the shared, and the next one is the exclusive, and the next one is the none. Okay, so here shared and exclusive both are the InnoDB row level locking. So you may already aware of it. So the shared means it holds the lock to read a row. Okay. So for example, the shared is for the read and exclusive for the writes. We can tell like it. Okay. So for if one transaction is doing the shared lock on a particular row and the other transaction is also trying to access the same row with the shared lock, then that is allowed. Okay, that is possible. But the other transaction is trying to modify, doing some writes, that is not allowed. Okay, so with the exclusive means that is the transaction. The first transaction is already hold the write lock on particular row, and the other transaction is trying to acquire, read, or write lock, then that is not possible. Okay, so I will show in demo so that it would be helpful and to understand better how both are working. Okay, and the next one is the none, which means I would say there is a no lock. Okay, there will be no lock during the operation. So this is my testing environment. I have installed the my Percona server, which is 8.0.28, and I have created the database class, and I have the table SP test1, and I have the my table is with InnoDB engine, and the table size is around 952 MB. Okay, so what I'm going to do, I have the running Sysbench. Sysbench is running, which will do the read and writes on the table. Okay, and how I am going to test the different algorithms and the different blocking means I will start the Sysbench. It will act as an application and it will do the reads and write on the table Hercules.sb test1. Okay, and we are going to test the alter algorithms one by one with all three locking conditions and see what is going to happen. Okay, so we have the three algorithms, which is copy, in place, and instant. We have the three locking options, which is shared, exclusive, and the none. Okay, so what we are going to do is we will first test the algorithm copy with the shared, exclusive, and none. Okay, then we will go with the next algorithm, which is in place. Then there also we will test with all these three, and finally instant. Okay, so this is the way we are going to test in this demo. So let's see a quick overview about this copy algorithm. Okay, so the copy algorithm means I would say there is a traditional method, and how the copy algorithm is working. Okay, so that is the next question. So it will create the temporary table, new temporary table, and it will copy the data from original table to temporary table. Once the copy of the data is completed, the original table will be deleted, and the new temporary table will be renamed as a original table. Okay, so this is quite expensive operation due to the locking issues. Okay, and here lock equal to shared and lock equal to exclusive, both are allowed. Lock equal to exclusive and lock equal to shared, both are allowed. Reads are allowed with lock equal to shared, and reads and writes are not allowed with lock equal to exclusive, and lock equal to none is not supported. Okay, so let's see how this is working in real life. Okay, so here I have two sessions. I have logged in the same server in the two sessions. So here you can see I have installed the MySQL Percona server 8.0.28, and I have the database Hercules, and there I have the table SB test form. Okay, so I have overall 40 lakhs of records in the SB test one table. Okay, I have overall 40 lakhs records. So here also I am going to log in the MySQL. So in this terminal, in the first terminal, we can execute the alter, and in the second terminal, we can monitor. Okay, we will use the second terminal for the monitor. Okay, so here I am going to, let me go to the varlib MySQL data directory first. So I would like to show something in the physical file as well. So I just go into the varlib MySQL and the database directory Hercules. Okay, so there we have currently we have only one table, which is the SB test one, and you can see the IBD file for the SB test one. Okay, so now let's log in the MySQL and show process list. There is nothing running at the moment. I did not start at the sysbench yet. Okay, so we can start the sysbench first. Screen-x sysbench. So here I already have the command. So I am going to do the OLTP read and write test. Okay, read and write test. And I started. Okay, so sysbench is started now. Sysbench is running in the background in the screen. Okay, and if you check the process list here now, you can see the queries. Okay, here you can see the update queries, which is for the SP test one table. Update SP test one table. I have two threads running with the suspense, so you can see the two queries are running at the moment. Okay, so you can also verify the master status. You can see that is keep moving. Okay, from for the last two numbers 89 to 97, 97 to 85. So which means some writes are happening in the table, SP test one table at the moment. Okay, fine. So here show create table SB test one. So this is my current table structure. I have 4 columns, ID, K, C, pad, and I have the primary key for the column ID. Okay, so now what I'm going to do, I'm going to test the copy algorithm. Okay, with lock equal to shared and lock equal to exclusive and lock equal to none. Okay, and let's see what is happening. Okay, so now I'm going to add the index. Okay, and let's see how it is. Alter table SP test one, add index idx underscore k for the column name, which is k, and algorithm equal to copy and lock equal to share. Okay. Yes, I'm just starting the alter, and let's see the process list here. And if you see the process list here, my alter is running. My alter table SB test one add index, which is running, and the current state is copy to temp table. Okay, because which we see that when we are using the copy, it will copy the data from old table to temp. I mean the original table to temp table. Once the copy is completed, then it will stop the temp, right? So here copy to table temp table, which is currently in progress. And if you see this update statements, this update and this update, you can see which are waiting for the metadata log, waiting for the table metadata log. And also, if you see the physically, if you see the file, here you can see one more IBD file is created, and the current size of this file is 772 MB. Okay, so that is the temporary table, new temporary table. So we see the how the algorithm equal to copy is working, right? It will work, it will create a new temporary table, it will copy the data, then finally After copied all the data, it will swap that table, right? So that is what this is the new temporary table physically. And you can see here the alter is completed, right? The alter is completed. And let's see again here. Now we have only one table because the alter is completed. The whole original table was dropped, deleted, and the new temp table was renamed as the original table. So currently we can see only one IPT. And if you see the process list now, queries are running as usual. There is no logging at the moment. Okay, so here what I would like to say how the copy is working. To create the new table. So here is a proof. It is creating the new temporary table, right? And here log equal to shared means it is doing the waiting for the metadata log on the write statements. Okay, it will write only on the write statements. So reads are allowed. Okay, so here you can see the update is waiting for the metadata log, and here the next update which is waiting for the metadata log. Okay, so this is what I would like to say with this algorithm equal to copy and log equal to share. And now let's drop this index and we can recreate the index with the same statement, but log equal to exclusive, and let's see. Okay, alter table sp test1 drop index idx underscore k. Dropping the index is not going to rebuild. Okay, it will be quite fast. Okay, so now let's execute the alter again with log equal to exclusive. Exclusive. Okay, so we previously we run algorithm equal to copy and log equal to shared. Now we are going to run algorithm equal to copy and log equal to exclusive. And let's see. Okay, I just started the alter, and here I'm going to monitor the process list. So here, if I see the process list, now select statements also waiting for the metadata log. So here you can see there is this select is waiting for the metadata log. And here is the one more select, which is also waiting for the metadata log. Okay, here we are using the algorithm equal to copy. So if you see the physically, then temp table might be created. Yeah, it is created. And you can see the temp table size from 512 MB to 576 MB because the data is copying from original table to temp table, right? So you can see this table is getting increased, size is getting increased. So see, now it is 800 MB. So once it is completed, then it will swap the table. Okay, still you can see the logs are happening, and this query is waiting for more than waiting for 52 seconds, and this is also 52 seconds, and waiting for the metadata log. Selects are waiting for the, the reads are waiting with the exclusive log. Okay, now the alter is completed, and if I see the show process list, now everything, the log was released, and everything is good. So I would like to explain how the copy is working. Okay, you can see the temporary file under the data directory, right? And you can understand the difference between the shared and exclusive. Shared means selects are allowed, only the writes are blocked. Okay, exclusive means selects and writes both are blocked. Okay, so that is the difference between shared and exclusive. Okay, fine. So now this alter is completed. Now let's drop the index and recreate the index with log equal to none and algorithm equal to copy. Let's try this, and you can see the query got the error like log equal to none is not supported. Recent copy algorithm record a log. Try log equal to shared or exclusive. Okay, log equal to none is not supported when you are using the algorithm equal to copy. Okay, fine. So this is about the copy algorithm. And the next one is the INPLACE. So INPLACE is introducing the MySQL 5.6, and it will not copy the data like the previous method. It will do the table rebuild in place. Okay. So here so in copy, it will create the new table and copy the data, then sort the table, right? But here how it is happening means it will create a temporary file, and it will log all the modifications, insert, updated it, all the modifications in the temporary file. when during the completion phase, alter completion phase, it will apply all the modifications in the table, then do the then the alter will be completed. Okay, so it will create the temporary file, it will capture all the modifications, and during the alter execution completion, it will apply the changes and alter will be completed. So this is how the in place method is working. So you can control the size of the temporary file using this variable InnoDB online log alter log max size. Okay, so you need to make sure you have the big size of this variable. Okay, when you are doing the big table, busy table, if you are doing some busy table, which the tables are getting frequently modified, then you need to make sure you have the good amount of size, some big number, 5 GB or 10 GB for this log file size. Okay, so that your alter will not get failed. Okay, if the temporary file is filled, then your alter will be failed. So you need to make sure you have the good amount of the size. Good size for this table. For this variable to allocate. And here the advantage is lock equal to none is supported. But in copy algorithm, lock equal to none is not supported. But in place, lock equal to none is supported. Okay, that is the one of the biggest advantage using the algorithm equal to in place. So now let's see the demo with the in place. Okay, so here I'm going to execute the same alter table add index query, which first shared and algorithm equal to in place. And the algorithm equal to in place, and I'm using lock equal to shared. Okay, I executed the query, and let's monitor the process list here. And if you see here, again, I am having the waiting for the metadata log, table metadata log for the write queries, for the updates, for this update also, I'm having the waiting for the metadata log. And if you see here, this altering, you can see the altering table, but for the copy to temp table, you will see the state, which is copy to temp table. But when you are running with the in place, it is altering table, because here we are not copying the data. All the activities is happening in the same table itself, right? It is just rebuilding table. So here you are seeing the altering table, but when you are using the copy, you will see the copy to temp table. Okay, so but when we using the shared, the locking is same. Here also selects are allowed, updates are getting locked with the waiting for the metadata lock. And here you can see the alter is completed, and it took around 17.96 seconds. But if you see this copy algorithm equal to copy, it might take some nearby 1 minute, 56. Why? Because it need to copy the data from one table to other table, and it need to sort the table. But here it don't need to copy the data, right? All the processes are happening in the same table. So this method is quite fast compared than the copy. Okay, so now I'm just dropping the index, and I'm executing the same alter with lock equal to exclusive and algorithm equal to in place. And let's see what is happening. Okay, just started the alter, and I'm seeing the process list. Here you can see waiting for the metadata log for the select queries. This is the same behavior we see in the copy as well, right? Waiting for the metadata log for the selects as well. Okay. And here also the table is in the altering table state. And here also the alter is completed quite quick, within 18 seconds, because as I told earlier, here we don't need to copy the data from one table to other table. All the processes are happening in the same table. So this method is quite fast compared than the algorithm equal to copy. Okay. So after the alter is completed, the logs are released, and they are running without any issues. Okay. So this locking, when compared to locking, shared and exclusive, both are happening same like copy, right? When we have the shared lock, selects are allowed, but writes are not allowed. Update deletes are blocked, waiting for the metadata lock. When you have the exclusive lock, selects and writes, reads and writes, both are blocked using the table metadata lock. Okay, this is same for copy and what is this? In place, both. Okay, same for copy and in place. But here we, but if you come to algorithm equal to copy, lock equal to none is not supported, but algorithm equal to in place is supported for the lock equal to none. Okay, you can run the alters without any lock by using the algorithm equal to in place. So let's see that. Now algorithm equal to in place and lock equal to none. None. I'm doing the same index creation for it. And if I see the process list here, you can see. Okay. Let me fix this. Actually, there is the commit running a long time. It might be disk issue. Yeah, my disk is filled 100%. So I need to fix this first. Let me fix this. Oops. So what is, okay, so actually I have around 15 GB of this, and I'm just removing this bin lock. This is not recommended, but still I don't have any other choice. So I need to update the index file as well. Okay, I just removed the bin lock, which is starting from 19, right? Bin lock 19. So I need to remove that entry from the bin lock index file as well. Otherwise it will create problem. Okay, so when you are removing the bin lock manually, so you need to make sure you need to update the bin lock file as well. Okay, so I did, and df-th. Okay, now I have 2094, and let me clear the other bin locks. Show binary logs. I think it needs, okay, cool. So I'm just going to purge the binary logs. Purge binary logs to. Show binary logs df-th. Oops. Okay, so now I have 43% utilization. Use surplus, and let's verify that all good. There was some commit was hang, right? Show process list. Yep, all good. Fine. So this is unexpected. My disk was full, so I just removed the binary logs and I just freed some disk space. Now all good. Now we can experiment. Now back to topic. We can experiment the algorithm equal to in place and lock equal to none. Okay. Um, yeah, it is started. And show process list. So here you can see my update is happening without any issues. There is no metadata logs, and my alter is also happening. And here also one more update which is updating. It is happening. So I don't see any locking issues when using the algorithm equal to in place and lock equal to none. Okay, so this is also completed, and I don't see any issues. Okay, so this is how lock equal to none is okay. Okay, so so we see two algorithms which is copy and in place. So we lock equal to shared and exclusive both are supported in the copy and the in place both algorithms. Lock equal to none is not supported for the copy. Lock equal to none is supported in the in place. Okay, that is a difference. So now let's move to the next one, which is instant. Okay, so which instant means this is introduced in the MySQL 8.0 file, and this is only going to modify the data dictionary. Okay, not it is not going to rebuild your table or not modifying data. So this we can call it as a just metadata change. Okay, so but it don't have the support for all the alters. It have the limited supports for adding the columns, dropping the columns, modifications, column change, default change modifications, etc. So you can get, you may need to know, right? So what are the operations it is supported and what are the operations it is not supported. Then I would recommend to go to this page. Here you can see all the, for instant and in place rebuild, whatever it is supported, you can see. For example, creating or adding a secondary index. Instant is not supported, which is no. In place is supported, which is yes. So similarly, for all the operations, you can get the details here in this page. Okay, so if before executing the details, you can get the informations, which algorithm you can use. Those informations you can get it from this page. This is very useful page. Okay, to know that. So fine, and now let's do that. Let's test the instant by adding the column. Okay, because adding the indexes is not supported with the instant algorithm. So we can try adding the column using the instant and see how it is happening. Okay, so here, so this is running. The system is running. You can see the update, and here alter table sp test1 add column te underscore id in not null default one algorithm equal to instant, and let's try the log. Okay, log equal to shared, and you can see incorrect usage of algorithm equal to instant and log equal to none, shared, and exclusive. Okay, similarly, you will get the same error for all those. Exclusive, same thing, same error. And when I am using the none, I will get the same error. Okay, so then how to execute the instant alter means you don't need to provide any locking options, just algorithm equal to instant is enough. Okay, so I just executed and the query is completed within a second. Okay, just took 0.73 seconds to add a column. Okay, so this is very, very fast. So as we see before, how the instant algorithm is working means it is just going to update the data dictionary and it is not going to rebuild your table or modifying data. Okay, just it is going to update the data dictionary. So it will be quite fast instant. But as I told earlier, it don't have the support for all the alters. It have the limited support. You need to check that document I show you, right? To know what are the operations are supported, what are not supported. And here one more thing I would like to mention from MySQL ALTER Algorithms 29, which is the very recent release. It has the support to drop the column as well. Okay, you can drop the column using the instant method, algorithm equal to instant. Okay, so this is about all the algorithms, alter algorithms with their locking methods. So let me quickly explain this. So we have three algorithms. One is copy, in place, and instant. Okay. So copy is supported with shared and exclusive. None is not supported. In place is supported with the shared, exclusive, and none. Okay. Instant is not supported with any of the locks. Okay. Just you need to provide the algorithm equal to instant. That is fine. So when you have the lock equal to shared, what happens? It will allow the reads, but it will not allow the writes. When you have the exclusive lock, it will not allow the reads and writes. It will block everything. Okay, you cannot access the table. And when you have the lock equal to none, it will allow the reads and writes, but maybe you can expect some locks during the table alter completion. Okay, when it will try to update all the modification from the temporary file, that time you may expect some locking. But lock equal to none, from my experience, lock equal to none is very good one to go with. Okay, but still, when you are doing the alter, it's in place and lock equal to none, you may get you have the asynchronous replication. There you may get some replication lag that you need to consider. Okay, so this is just a difference between the three algorithms. In place is supported with the lock equal to shared, exclusive, and the net. Okay. And instant is not supported with any locks, but it is very, very fast. You just need to use the algorithm equal to instant. That's it. Okay, fine. So now let's move to the next one, which is the parameter, MySQL parameter, old underscore alter underscore table. Okay, so let me explain this theoretically how it is working. So when this variable is enabled, the server does not use the optimized method of processing an alter table operation. Okay, so when this old alter table parameter is on, it will not use the optimized method. Okay, it will always go to the traditional method. Traditional method means algorithm equal to copy. Okay, when this variable is off, the server will use the optimized method. Okay, based on your alter statement, it will use the optimized method. So let's see the demo for this as well. So show global variables like old alter table. So by default, this is off. We cannot change this in global. So it will not work. Oh, sorry. It is working. Um, Let me see. Let me confirm this. Okay, so this is actually working. You can do this change. You don't need the MySQL restart. You can change this on global. Okay, but make sure you are reconnecting the session. Okay, after changing this variable. So I already reconnected. Now what I'm going to do, I'm going to execute the alter without mentioning. Yeah, I'm going to add the index without mentioning any algorithm and without mentioning any log. Okay, just I'm going to execute this alter table sp test phone, add index idx underscore k and column name is k. I'm just going to execute this alter statement and let's see. You can see waiting for the metadata log. Okay, for the update statements. Updates are getting logged, which means writes are getting blocked. And you can see copy to temp table. Copy to temp table means this is using the algorithm equal to copy. Okay, so this is using the algorithm equal to copy. And so I did not provided any algorithm or locking, nothing. I did not provided nothing. But when I execute just the alter, it is going to the copy to the temp table, and that is the algorithm equal to copy. It is going to the traditional method. Okay, that is what I am coming to say. When this variable is on, old alter table is on. Okay, and I did not provide any algorithm, and I did not provide any locking. It is going to the traditional method, which is algorithm equal to copy. Okay, so now let me off this variable. I'm just disabling the old alter table and I am reconnecting and I am going to execute the same alter with the just changing the index name because the index is already existed. So I'm just changing the index name. I'm just executing the alter without providing any algorithm and none. And now see the process list. Now if you see my delete is executing and here also altering table. This is not the copy to temp table, right? So this is just altering table and my delete updates, other queries are executing. You can see the updating. Okay, there is no logs. Okay, so when this variable is disabled, okay, old data table is disabled, the server will choose the optimized method. Okay, so here it choose the log equal to none and algorithm equal to in place method. Okay, so that is what I'm coming to say. I mean, I wanted to show the difference between old data table enable and disable. So if you disable that variable, what it will do, the server will choose the optimized way to execute the alter And if you enable that variable, it will always go to the traditional method, which is copy method, algorithm equal to copy method. Okay, so this is the role of the old alter table parameter. By default, that is disabled only. So we are good. So whenever you are executing in the alter without algorithm and lock, then it will just choose the optimized way and run it. But if you enable that variable manually, then you need to make sure you are providing the proper algorithm and the logging things. Okay, so this is what I would like to share in this presentation. So hopefully this is useful. Maybe you have some questions or comments or concerns, whatever, please let me know. Okay. Thank you so much. Bye.